Okay, welcome to this I'm going to keep this video very short and brief and just give you a couple of guiding principles at different stages. If you're a competent and advanced student, you probably won't need to spend too much time on this video. If you're less experienced and you're new to Java and you want some initial starting points, then this might be more useful to you. Okay, so the very most important thing to say is that so much of the basic coding is already available to you in 7a and 7b, and if you go to Moodle, the project used in the live lecture and that live lecture I gave you can give you a good starting project. You could start with that, rename it and rework that as the base and adapt it into the coursework. That would be a sensible way to approach it. And if you're trying to think, well, how do I adapt it? Well, Smart Light is pretty much the coursework smart plug with changes, right? You know, the location concept disappears, for example, and the smart building can be adapted into, where is it? Smart building can be adapted to make your smart home. So you've got two basic classes that you could design using 7a, and I'd also recommend going through 7b and building all of those things. And making sure those two bits will work, and then adapting, refactoring that code, removing variables, adding in member variables, adding in methods, removing methods. Probably the fastest way to get into this. But let's just talk about the grading process and how it all fits together. The scenario, I'll let you read the scenario in your own time. Essentially you've got a dashboard, and you're going to display a dashboard of smart plugs. Okay, I'm not sure if I did that with the week 7, but I'll let you. You have a number of options, and you select an option, you change some value, and then you display this dashboard again. And that's essentially, after you've set it up, that's essentially all the console will do, right? The real work is making sure the code behind these options or functions, well, all of them, not necessarily. And so let me give you some guidance. First thing to note is these constraints are absolutely critical. Okay, if you break these constraints, you are likely to lose marks, and so treat these constraints as grading, influencing grading decisions. This is crucial. Responsibilities: back-end objects, front-end objects. Don't put front-end stuff into the back-end, and don't store data in your front-end that should really be in the back-end. If you are temporarily holding on to something in your front end, say you temporarily create an array in your front end, and just before you delete it, before you do something else with it for the scope of a function, that's okay, that's permissible. But any long member variable stored in the front end that cuts across any object that lives in the life of the object, the only one that you really want to do that with is the smart home. Okay, and your console object. Okay, so that one's not so complicated. The user interface isn't, just to encourage you to do integer-based input as much as possible. Why? Because the project is assuming you're going to just have good input, and actually in practice, your video demonstration, remember this is a video demonstration, which is worth 10%. Wherever it's gone to, wherever my instructions gone, and down here somewhere. Yeah, so you're basically going to demonstrate it. So the point is that you don't need to then get hung up about, oh, if I enter A when I should have entered 1. If we're assuming you got good input, then don't get distracted by exception handling. There's not much teaching in it. There's a tiny bit in your 7b to do with what's called a recursive. There we are. There's a recursive in here, a recursive one. You're welcome to use that or adapt that for your purposes, for your coursework. If you do take code that you've adapted, make sure you mention in the technical report that you've taken legacy code, and you can call it legacy code that I've supplied that you've adapted, which is perfectly permitted. Okay, libraries again. If the coursework was just about building a piece of software, you could probably do it using array lists, much easier. Well, you could do it using array lists, but the point is it's not that. The point of this, to you to learn, is for us to see your thinking process and building the mechanisms yourself. You will lose marks if you go this path of using all the libraries to get it all to work for you. It's just not, it's worth pointing that out. And finally, perhaps the most important one is that we don't want your code to be overcomplicated. Whether you like a piece of code or not, whether you like doing things in a certain way, I'm not interested in at all, and no one will be. What we're interested in is you solving a problem in the cleanest, simplest way possible. If you end up using a slightly complicated coding structure, make sure you justify it, because if you don't justify it and it just seems that it's a personal subjective thing, you'll lose marks. It'll be treated as overcomplicated. Also, we're not expecting any extra functionality, so don't just add things in. Think, oh, but you might need this in the future, or but you might need that in the future. No, don't do any of that. Don't go adding stuff in and the possibility of this and the possibility of that. I'll give you a very good simple work experience example. I had a colleague who kept on doing it, and actually what ended up happening was this colleague ended up adding all this extra functionality, and the customer said, we will never use that because our intention is to do this with it. And the person had wasted weeks and weeks of adding extra functionality, which on principle looked like it would be really useful, but they had no idea what the direction the future project would go. So don't do it, and don't assume you need to do it to get more grades. You won't. You will lose points. So the constraints are crucial to remind you, and always bounce back to them, of things that you will potentially lose marks on if you don't pay attention to them. This coursework is worth 25%. The whole coursework is marked out of 100. So you can literally treat 80% as the development, and 20% is for a report and video. Now, that means that you can get very close to passing it just by demonstrating whatever you build correctly. Don't have to complete it in order to get these grades, and writing a good technical report. Now, why a technical report? Technical report shouldn't have description in it. I did this, I did that, I did this. No, what it should have in it is explanations of your decisions of coding. So the easiest way to write the technical report is to say, here was a problem I encountered, and this was my approach because. And we're interested to hear what you would write in the because. You can put code snippets in to show, but we don't want the description. We want to know the because, the reasoning behind it. That's crucial for final year projects, incidentally, and it's an excellent skill to have when you're doing this kind of work. But that's an easy, relatively easy 20%, right, to get. And the nice thing is that when we go to the task breakdown, the first 10% could be done in 20 minutes, 5 minutes by some of you. Some of you, I'm hoping, most of you already have your own console helper object. That's worth 5%. And actually to build the main, the home, is worth another 5%. And you think, oh, what's that talking about? Well, just go back to week 7 and have a look at how I've done it, because there is a variation, very nice, simple variation for you to look at. Okay, so that's an easy 10%. So we're almost around the 30%. Let's say that you're around 25% of this is based on what a video, technical report, and material, hopefully, that you shouldn't find difficult to do. So you're already approaching the pass mark just by hopefully have understood what we've been doing this semester. Then we come to the system setup. Now, system setup is worth 20%. And interestingly enough, the system setup could get you through the pass mark if you're worried about it. So it is designed to help you nudge over and pass if that's all you feel you're able to do, but obviously give you more scope for greater grades. So the first 20% are all about setting up the number of rooms, the number of plugs. The simplest way of doing this is actually creating 2 arrays, one of rooms, one of plugs, to store this. When this task 5 comes, it asks you for the names of the rooms. So what it's trying to do is for each room object, and it creates an ID for it and a name. And you think, where's that information, Nad? I don't know. Go down to the appendix. And the appendix, if you scroll further down, it says the room, name of the room, and ID. Now, you might say that says optional. Why should I do it? Because you don't have to create an object. You could, there are ways of doing this that, although they're not the best practice, they can get you through. You can create a single array for the plugs, and for this you could just store this information while you're building your plugs. Now, if you do that and you hold it in the client and then it disappears after you leave that, set up methods and functions, you don't store it as an object inside. So you don't store an array of rooms inside your client, as a member variable inside the helper. If you don't do that, or inside your main, because that will break the first constraint, that data stored should always be in the back end. Then there are simpler ways of doing this, and you may not, but the only risk of doing it the simpler way is that it will automatically limit you from getting the higher grade. To get the higher grade, you really want to be creating a private array in the back end of rooms. So I'll leave that judgment to you for you to make. Then in task 5, you're basically going to populate your rooms. So all you're going to do here is you're going to say how many rooms. You've got 4. You create a loop somewhere, and then you just get the names of the 4 rooms. And then in task 6, you use that information, you attach a number to it, so you build each of the plug objects. And you do it by getting a room and an attached device, sending that information back to the smart home. It's a very simple and analogous example in the smart light switch in week 7a. Where is it? There's an update, updating and accessing, there's an update method here. No, it's not the one you want. You want the add method here. There you go. This discussion here. So that is what, some variation on that on page 8 of week 7a is what you would need to support task 6. So that's worth 10%. That's the asking that is worth 5, so that's 20%. So you could comfortably pass just by getting that far before you even hit part 2, which is basically all about displaying the options and putting methods in to deal with each of these level of options. So it's worth bearing in mind. Then you have part 2, which is worth 50%. Actually, only 35% is for the house, the room, and the plug. And so, for example, here, you whether you want to turn them all on or off. So you'd have a method on your smart home called switch off, switch on, for example. Could have parameters, might not have parameters. That's a thing that you might want to think. You have a similar thing in the rooms. You select a room. So the issue for you will be how you're going to actually process this in the back end. How you're going to identify all the plugs that belong to a room. Then you can switch them all off, or you can toggle them. And you think, toggle, what does that mean? Well, if it's on, you switch it off. If it's off, you switch it on. And the easiest way to do that is in your smart plug. Create a toggle method that you can call once you've identified that's the plug you want to toggle, for example. Okay, these options get more interesting. Options 1 and 2 for the smart plug itself. To change the attached device. So if you think about, we go down to look at the smart plug, it's got an attached device object, right, which is stored inside the smart plug. You're literally changing the name, or you're reallocating the name and potentially the ID. All depends on how you have coded it. Okay, so you've got these slightly more complicated 3, and these 10% here and 10 and 11 are more complex, but essentially they're all about identifying an object in your array and then editing a value inside that object, that smart plug. That's essentially it, and the same mechanism and pattern repeats itself. It's a critical pattern of coding for anyone working in software. Then the last 15%, which would take it from 85% up to 100, is all about these system level options. I'm going to say very little about them, other than if you want to seriously go for the top grade, you need to store your rooms and your attached devices as an array of each of them. And then when you put them inside the smart plug, you have an object of that particular smart room, not smart room, but room or attached device. You don't want to hack these early tasks where you can, in theory, ask for a list of names hold on to them in your client temporarily, and then just for task 6, pop them up and then display them. That has huge limitations, so think really seriously about it. You can get away with hacking it, because we're looking at functionality, remember, as well for these early tasks. But if you really want to hit the high grade, then you would it's worth really thinking about. I wouldn't recommend, if I were you, to go and do every single task. I would do each other section of tasks as an overall strategy. Perhaps the most useful thing to you is to think about how you're actually going to put your smart home together. So in week 7, I had a smart building, and I only had one array, and they were smart light switches, right? And they hold a smart light switch object, an array of them. Now you have to ask yourself whether you're going to have one of attached devices or rooms, and then use that data and access that data from the smart home and make it available. So if someone says to you, add a room, right? You have an add a room method. Here we have an add method only on adding smart lights, but you could easily adapt this. So you have one called add room, one for add attached device, one for add plug. And you could, the code is a variation on itself. So it's worth really thinking that through. Often a lot of these techniques in software are once you've mastered it in one corner, you just vary it and you've got it in another corner. I'm not going to spend much more time because I'm sure you need more time just to get your head around it yourself. But week 7 and week 7A and 7B plus the project use might be an easy starting point for you to refactor, rename, and get started with your coursework. Okay, so very finally, as I said, you have a technical report, 10%. It's 1,000 words, plus or minus 10%. And we're not looking for every single description of everything you did. Please understand this. It is about your reasoning process. Again, you might have so much thought you put into it that you think, I can't fit it into 1,000. So pick the key decisions, the things that you think demonstrate your real thinking capacity and how you've approached a problem. That's what I want to see in here. That's what we ask final year students to do on a much bigger scale. Essentially, your final year project is all about this, explaining, justifying, showing that you thought it through. So you're getting a little piece of that here. And the video demonstration is, if you don't do it, we can't see your demonstration of your code. It's a critical part. You'll lose 10%. And if we're then forced to open your project to run it and it doesn't behave, you're likely to fail. So this is your easy opportunity of you presenting your work and demonstrating all the things you've done and taking away any risk of you being poorly assessed. Okay, and it's worth 10% independently, but it will also contribute towards a question of the functionality. When I work out, when we say, did this person do this bit here, and you don't demonstrate it, well, then we won't know, right? Did they do the room level stuff? Well, if it's not in your demonstration, we won't know. Your demonstration is there to show the functionality of what you've done. Okay, and it's straightforward. The system component is brief at the end, but it might just provide you with some really basic pointers, and that's pretty much it. What I would recommend is, if you have questions, use the subject Java coursework, ping me the question. If it's useful, it will go in the FAQ. So what you notice is that we've set up a Discord channel for those who want to use Discord, but independently of that, I'm creating a FAQ, and in that FAQ I'm answering questions which I hope are of general use to all students. So as we progress through the weeks and I see a repeated question, I think that might be useful for everyone, I'll pop it into here. So please get used to consulting that. There's 2 very useful questions that have come so far that I think are of general use. In this second one, in what ways can I get assistance with the coursework, was a question that someone emailed me with, and I've just adapted it. And of course you're allowed to ask for help, but this is quite important. The staff won't code it for you, but they will guide you, they will help you as far as they can but we want to encourage you to think through the problem. And if you get stuck, something doesn't work, obviously that's where we come in. If you think what's the best approach to something, we can advise you and encourage you, but it's your work. We don't want to end up doing your coursework for you, is what that question says. And what else would I say here? This was a very good question that actually prompted some ideas here. And the first question is, does the smart plug create a room object, or can I use a room array inside my smart home? Actually, you need both. What I'm trying to hint at is if you're going for the top grade, you really do need both, because you need a way of storing rooms independently of smart plugs. And then inside the smart plug, you need a way of simply allocating a particular room to that smart plug. The easiest way is just having an array of rooms which you can independently maintain, increase, shrink, which is what the advanced, for those of you going for the system level options, the remaining 15%, which take you up from the 85% up to 100, it's all about more smart plugs being able to be added, more attached devices, and more rooms. Easiest way to do it is you have one mechanism that you've worked out how to do it once, you're just varying it 3 times. How you code it is up to you. Okay, thank you.